So this is chapter 13, talking about light. So what we're going to do is we're only going to do two sections of this today. So let's go ahead and get started. So on here it has characteristics of light. Electromagnetic waves, a wave that consists of oscillating electric and magnetic fields which radiate outward from the source at the speed of light. So as it's rotating around that axis, they both have different wavelengths. Frequency times wavelength of electromagnetic radiation equals c, which is the speed of light. So the speed of light equals frequency times wavelength. Sample problem A had a question, and it says a range of 6.98 times 10 to the 8th hertz to 7.46 times 10 to the 8th hertz once the analog TV channel is now used as a 3G and 4G cell phone. What is the longest and the shortest wavelength of this frequency range? So what we're going to do here is we have our frequency of ranges here, and then we have our C, which is our constant. So let's look and see what we have here. So, which is our speed of light, sorry, which is a constant. So here we go through and we take our constant divided by the 6.98 first, and we get 0.430. And then the second one, we take the 7.46 divided by the speed of light, which is 0.420 meters. Okay? So the first problem says that a gamma ray burster are objects of universe that emits pulses of gamma in high energies. The frequency of most energy bursts is measured in 3.10 to the 21st hertz. What is the wavelength of these gamma rays? So we're going to first start taking by the intensity, which we have 0.25 watts over 4 pi times 5.0, which gives us 8.0 times 10 to the negative 4. The second intensity, we have 0.50 watts, and that's going to times the same thing, and we're going to get 1.6 times 10 to the negative 3 watts per meter square. And then the last one, which is our third one, which is 2.0 watts, which gives us 6.4 times 10 to the third watts. Number 2, what is the wavelength of an FM radio with 80 to 108 hertz? So we're going to do 70. And we're going to take our 25 meters. So we're going to take our 70 divided by 2 pi, 25 meters square, which will give us 8.9 times 10 to the negative 3. So I only did 2 of those. So then it talks about waves can be approximate as rays are. We have the Eugen principle, which is a wavefront can be divided by the points of the source. And then it talks about illumination, and it decreases as a square of the distance from the source. And then the brightness of a light is inversely proportional to the square of the distance of the light source. So then we go into the second unit, which is flat mirrors. Refraction is the change in direction of electromagnetic waves at a surface that causes it to move away from the surface. We have a texture of a surface affects how it reflects light. And then that is specular reflection. And so then we have a diagram where it shows incoming light and reflective light, and shows that the normal and the reflective source and the angles for those. And then we have 2 definitions: an angle of incident, which is an angle ray that sticks to the surface, and the line perpendicular, so that the surface at the point of contact. Then we have the angle of reflection, which is the angle formed by a line linear to the surface in the direction in which the reflection ray moves. We have virtual image, which occurs when the ray appears to come from the location diverge, even though they are not actually focused there. And a virtual image cannot be projected on a screen. And then it has a ray diagram where it shows you how to do the ray. The other thing that I would say is that make sure you understand that the light obeys the law of reflection, which states the incident and the reflected angles of the light are equal. And the flat mirrors form virtual images that are the same distance from the mirror surface as the object is. The next section we will go over in our next lesson. I hope you have a good day.